This is a recording of the answer key. You will find the file in the Canvas website. I also wanted to give you a narrative of this answer key, a short narrative on some of the key questions that, based on the office hours, seem to be a little bit more problematic. So I'm going to skip the first part on short questions. I expect you to know how to define life expectancy, differential attrition, reverse causality, confidence intervals, and I'm going to move directly to the explanation on question 6. So question 6 says, a researcher is interested in studying the relationship between calorie intake and earnings. There is runs a regression. This is the regression, earnings as a function of calories. Now, he wants to estimate alpha 1. Let's call that alpha 1 hat. And because he's worried about omitted variable bias, he adds education on the right-hand side. So the regression that he runs then is earnings on calories and education and a constant. So now the question that is this beta hat 1. And the question is, how does this beta hat 1 relates to the alpha 1? Now, remember that when you have omitted variable bias, it's all about how the omitted variable is related to the explanatory variable and to the outcome variable. In this case, we expect that the education is positively correlated with calorie intake, and it is positively correlated with earnings. And because there is a positive, then we would expect that this alpha 1 coefficient is going to be biased, and it's going to be biased upwards relative to this beta 1. So we would expect that alpha hat 1 is greater than beta hat 1. Now, second part, suppose that the researcher conducts a randomized experiment. So he randomly assigns half the village to get meal supplements and half the village in control. Then he runs the following two regressions. The first regression is earnings as a function of assigned to 500 calories. So notice that this is the intent to treat variable. This is a dummy variable equal to 0 if you're in the control and is equal to 1 if you were in the treatment group. The second regression, you do the ITT and you're adding education. Okay, now the question is how alpha 1 and beta 1 are related. Now the short answer is that alpha 1 ought to be equal or very close to beta 1. These two are going to be the same because, why? Because the assignment to the treatment, this one, was randomly given to people. It's an RCT, and therefore it doesn't matter how many controlling factors you include, such as education. The point is that you include them, you exclude them, you should get the same coefficient estimate. Okay, that's the beauty of the RCT, that the treatment effects should be constant regardless of how many controls you add. Now, what's the actual explanation as to why it's the case? Again, for the bias to occur, we need to see that beta 2 is going to be, that education, the omitted variable, should be correlated with the assignment to 500 calories. So there should be a correlation between these two, and then education should be correlated with earnings. Now, it's clear that education is correlated with earnings, with the explained variable, but cannot be correlated with alpha 1 because because alpha 1 was randomly assigned to, the assignment to 500 calories was randomly assigned. So there cannot be any correlation between this random variable and the education. Okay, so because there is one of the two pieces are missing, there is this lack of correlation between the education and the assignment to the treatment, that we don't have to worry about omitted variable bias in this case. Okay, so hopefully that is a clear enough explanation as to why the answer is alpha 1 equal to beta 1. Now, let's keep going. Here, this is something we haven't covered yet, or it's not expected to be for your exam. Now, the question 1, here I want to be clear about how to write the regression. Okay, so now we have two sets of individuals, two treatment sets. One is student in classrooms without assistance, and then we have students in classrooms with assistance, where we have done a randomized assignment of pupils or classrooms to assistants. What we see is that students without assistance get a grade of 76.5, students with assistance get a grade of 79.4, and then what is the generic regression needed to estimate intent to treat? Okay, so what we need to do here is create a dummy variable that is equal to 1 for those students that are assigned to an assistant. So here it is. This is the dummy variable assigned to assistant. This is equal to 1 if you were assigned to the treatment. And then what we're going to do is we're going to regress grades on a constant term plus beta 1, the intent to treat, which is assignment to the treatment, plus an error term. Okay, this is the intent to treat regression. Now, write the regression with the actual coefficients. Here we need to think about what ought to be the average coefficient estimates for the students in the classroom with assistance and without assistance. Now, if you are in a classroom without assistance, that means that this coefficient, this dummy variable for you is going to be equal to 0. So grades for the children without assistant is going to be equal to grades equals to beta 0 plus beta 1 times 0. So grades for those in the control is equal to beta 0. So beta 0 is going to be the average grade for classrooms without assistance in the control. Again, why is it that beta 0 is equal to 76.5 that we see here? Because when you look at children in classrooms without assistance, those children, you see their grades, you see that this treatment dummy is equal to 0, and so their grades are equal to beta 0, and your estimate for beta 0 is just the average grade, which is 76.5. So grades for children in treatment in the control is equal to 76.5, and that's the constant. Okay, so the constant in intent to treat is always the mean of the control group. Now, what about beta 1? Well, beta 1 is assignment to the treated, to assign to the to be an assistant. So what is the grades for a child that is assigned to be to receive an assistant? His grades are beta 0 plus beta 1 times 1. Okay, the dummy variable for those children is equal to 1. So beta 0 we know is 76.5 plus 2.9 times 1, that gives us 79.4. Okay, so to compute beta 1, all you need to think of beta 1 is the difference between the grades in the treatment relative, it's the grade of the treatment minus the grade in the control. Okay, so hopefully that kind of explains. To summarize, when you write down the regression correctly, grades equals to constant plus beta 1 times assigned to the treatment. The constant term is the average for the control, and the beta 1 coefficient is the difference between the average for the control and the average for the treatment. Okay, so what is the coefficient for the intent to treat? That's 2.9. Suppose you run the regressions data and the standard error is 2.769. Is the coefficient significant? The answer is clearly no. The coefficient estimate is 2.9. The standard error is 2.7. 2.7, if you were to double this, you get something a little bit over 5, and this is much smaller than 5. So this clearly is not statistically significant. Now calculate the economic magnitude of the ITT estimate. As we've seen, to calculate the economic magnitude of the ITT estimate, you take the ITT, which is 2.9, you divide it by the average of the control group, which is 76.5, and you get 0.0379, which is 3.79%. So the treatment has changed grades by 3.79%. Is that large or small? Well, it is insignificant to begin with, so you might be willing to dismiss it. On the other hand, you could, and in addition, an increasing grades by 3% doesn't sound like much. On the other hand, you could argue that it is fairly large because it would move you from, say, a D minus to a D, or from a C to a C plus. Okay, so it allows you to, it allows your grade to increase by some. Okay, so that's that. Finally, on the last question, what we have here is a set of regressions where these are the outcomes, and these are the intent to treat results. Okay, so this is a true policy that they did, where they gave these computers that people were very excited about less than 10 years ago, these EXO laptops, $100 laptops. They're very cheap to produce, and they also were pretty crummy as computers. So this is the impact evaluation from those giving children in Peru a bunch of computers, and you can see that it did have an impact. Giving them a computer have an impact on their ability to use those computers, which use a particular operating system, but it didn't seem to have changed much their ability to use PCs or internet. Okay, so the comparison between winners and non-winners is essentially zero. There's no difference. And yeah, so it didn't help them learn how to be digital netizens. It didn't seem to help them with math. It didn't seem to help them with reading. It didn't seem to help them with cognitive skills. And if anything, it seems like it has given them a reduced their the amount of time they spent in the classroom doing work. So. So columns 1 and 2, whoops, I forgot to write this. Columns 1 and 2 are not regression columns. What are they? These are just means for the winners and the non-winners. And then, sorry about that. And then we have the regression. Okay, so regression for column 3. The outcome variable is the test. This is the mean for the control. This is the average, the ITT, and that is multiplied by the by whether or not you were a winner. Okay, and then and that's it. Okay, so that's pretty much what I wanted to share. Good luck with your exams.